Okay. Yeah. Can you hear me downtown now? Raise your hand if you hear me. Okay. Thanks. Yeah, mic was up there. Okay, I've opened lecture number 16 from WebCT, and I clicked on the PowerPoint lectures. You see now that it does come up in a new window. Now, over here, it behaves the same. So there are two places you have to go in to change the settings in this portion here, and then over here in course menu. So the software doesn't let you go in and change it in one spot, and it carries over to both. The original setup, you tell it to go to both locations. So when you originally set it up, if you told it to open in a new window, they both would. But to change it, you've got to go to. So with the PowerPoint presentation in a window, and I don't have the right lecture sequences put together. Today is the 3rd, isn't it? Look at that. Our lecture's up there already. Oh, they're waiting for us. Okay. So just because I'm determined to do it. So this is the grand scheme for all of this, and I know I don't have the slides set up correctly, is that you would have the lecture slides available, and the challenges are labeling. We label the streaming video by date, not by the lectures that it covers. We don't have our slides numbered, so there's a lot of shortcomings, I know that. And so it requires more input, more effort on your part to pause this and open the appropriate presentation on campus. They both open up quite rapidly. My computer's at home, even with Roadrunner, early in the morning when it shouldn't be peak time. It takes a bit of time, so I'm testing this and noting that's kind of a work effort on your part. So I do appreciate that. But this is the grand scheme, so that if you can't read what's on the slide in the streaming video, you at least have the audio and can follow the mouse, the cursor, when we're pointing out certain structures on a slide, especially one that comes up in the earlier lecture today. So I'll leave that open since we have it. So that is the scheme. I have changed all the way up through lecture 25 on both of these sites here within the PowerPoint link, PowerPoint lectures link, and over here on the course menu. It doesn't go backward too far behind I think 10 or 11. So everything is still, of course, a job in process, and I'm continually appreciative of everybody's effort, and happy, as I've stated before, that everybody is paying those fees, and it helps us to get assistance to put together what I think can eventually be really a nice package of an online system that helps people to take these types of courses. So enough selling the system, I guess. Let's get back to our lecture material. So we're very close. We're just about a half a lecture away from the syllabus. I think that's quite reasonable, as I'm racing all over the city to get to you, and I appreciate your patience in the first few minutes of each lecture, waiting for me to arrive and so forth. We are talking about the embryonic body cavities, and it's very important to spend our time on this because we're building our three-dimensional feel for the developing embryo and the development of a fetus. And as we're trying to visualize the body compartments falling into place, we're seeing changes in the organ systems, as we said, that we're going to look at later. So this is that effort to put together the three-dimensional aspect of the whole organism as it's developing. And we recall that we started with that horseshoe-shaped structure, and we are following that. So I'm going to try to pick up the mouse cable here. So we're thinking of a horseshoe-shaped tube, and if you bend the front of the tube down in like this, and then you take a section, you're going to see both the top part and the bottom part of this U-shaped structure. So that's what's happening in the embryo, is there's the bend in the U-shaped structure so that the curved part of the U comes and falls ventral or anterior to the original part. So the pericardial cavity is at the curve, and it's going to come from in front of the head down under the chest cavity, and that creates the bend in our horseshoe-shaped structure. And the pericardio-peritoneal cavities are the connection from the pericardial cavity all the way back to the peritoneal. And they are going to end up surrounding structures in the thoracic cavity. So we had seen this slide, and I just wanted to go back to get oriented again. We are going to follow the development up to this point as we continue through the remaining slides. So this is the first slide where we saw the two legs of the horseshoe in the same plane as we saw the U-shaped bend at the tip of it. So it has bent around underneath, and they now show up in the same plane of section with cross-section. And we saw how that is beginning to change, and there's this relationship of the mesoderm to this body cavity that differs in shape as you go from head to tail, and we create the visceral and the parietal layers, visceral layer on the organ, parietal layer on the body wall for the pericardium, the pleura, and as we will see on the abdominal structures, the peritoneum. So this was the slide that we had stopped at, and we're seeing this embryo. There are many somites at this stage, and it's about it's a little more than 3 weeks, so 24 days. So 3 weeks, 3 layers. By the end of 3 weeks, breaking into week 4, a lot has happened. Lateral folds, head fold, tail fold. The heart is already in place in the chest cavity. So the prochordal plate is around here somewhere with the buccopharyngeal membrane, or the oral, the opening, the future opening of the oral cavity. So if we make a cross section through this area, caudal to toward the tail, caudal to the pericardial cavity around the heart, we will not see the pericardial cavity, but we should see the pericardio-peritoneal canals, and they are shown here. And it's actually at the level where we see the septum transversum. So the septum transversum falls into place. It's mostly mesoderm that comes in, and it is separating the future thoracic cavity from the abdominal cavity, abdominal pelvic cavity. So the pericardio-peritoneal canal is is present at this state as an opening between the the future pericardial and pleural cavities and the peritoneal cavity. And we know that that has to close off so that we've got the diaphragm in there. It has to be, the thoracic cavity has to be sealed off so that when the diaphragm contracts and lowers into the abdominal cavity, it creates a vacuum. So it has to have a vacuum seal. So eventually we are going to see the septum transversum and other related structures in this area contribute to the closure of this pericardio-peritoneal canal. And that's basically what we're up to as we proceed through this. These panels C and D are showing us a view with the heart removed. So it's a lateral view with the heart removed from the pericardial cavity, and the arrow is showing us the continuity from the pericardial cavity all the way through the pericardio-peritoneal cavity near where this common cardinal vein is developing. It's important to see that at this time because that's going to contribute to a fold that's going to come in and help separate the thoracic cavity. So there's a vein right here, and this is going to point out that the vasculature develops very early. We stated that because we need to get the circulation going. So everything else really is going to develop around the vasculature and, of course, the other organ system that's developed very rapidly and early, the nervous system, and, of course, the gastrointestinal system that is basically being sucked into place as we get the folding of the embryo. So we'll see blood vessels in many different locations. We already talked about it being in the mesentery, but they're going to be in structures that are going to contribute to folds and elevations and things like that. So there is this continuity of this whole cavity that we've been saying over and over again. Now we have the wall of these structures. Yes. Oh, yeah, go ahead. That's fine. So now we're looking at this structure as kind of a bent horseshoe-shaped balloon, if you will. We all know those long balloons that the clowns work with. So now we can picture one of those long balloons that we have bent, and then the front part of it, where it's the U-shaped, we've rocked it under a little bit. So we're looking at that balloon from a lateral view, and we see the pericardial cavity, the pericardio-peritoneal cavity, and the pericardial cavity that would be inside that balloon. So that's what this view is. We're looking at the position of this balloon, and there is still an opening where the yolk stalk comes out, and so there is a continuity of the extraembryonic coelom and the intraembryonic coelom. So very early on with the embryonic disc, we saw the extraembryonic coelom created, the intraembryonic coelom and the lateral mesoderm created. They continued to form, the intraembryonic formed the U-shaped structure, and the extraembryonic coelom was there, and then they reached a point where they were continuous, and we're still continuous at this point. We have to change that for the normal closure of the internal body cavities from the external environment. This is the reason that the authors dedicate so many figures and so much text to this. The closure process and the separation process of this balloon is extremely important. If it doesn't occur properly, there's big problems, and that's the final part of the lecture that we'll see. So let's follow through on that, the changes that occur. This now is a coronal section, as we're seeing through the chest cavity. And panel A, it's at 5 weeks. Panel B at 6 weeks. We'll be interrupted with another view, but then we'll go to 7 weeks and 8 weeks. So we're passing the 4th week that we just looked at, going to the 5th, 6th, 7th, and 8th. So we're following the progression of the alteration of the walls of this balloon that we bent into a U shape and then pulled the front end of the U down. So there's going to be things that come along. Now we're going to picture like pencils being pushed into the side of the balloon, and other structures are growing around it. The heart's getting bigger, the liver's getting bigger, the lungs are starting to develop. So there's things that are going to push against this balloon that the clown started out with that's long and cylindrical. It's now twisted and bent, and now things are going to push into it and contort it, and until the analogy isn't the greatest, but just think of the balloon, when we twist it, and then it'll just close off, and now we've got a separate compartment of the balloon back here, and then we can twist it again, and we get just another compartment, and then the remaining compartment is the tip of the U-shaped. So we end up with 3 subcompartments completely separated by structures that push into and fuse to close off this one continuous tube into 3 major subcompartments, one around the heart, one around the lungs and related structures, and one around the abdominal structures. So this section through the thoracic region, this heart bulge is very prominent, very distinctive. So as well, we want to have a section through this area to watch to follow the events related to closing off the continuity of the pericardial cavity with the pericardio-peritoneal or future pleural cavity. So we see the common cardinal vein in this area. So as I said, a blood vessel is going to push into this balloon, and then the lung buds are, at this stage, are the bronchial buds. They're pushing into this space and bulging into the balloon, and it creates these folds, the pleuropericardial folds. So a question could be asked, what structure is found within the pleuropericardial fold? The common cardinal vein, so left or right. The phrenic nerve is also found within the pleuropericardial folds. And you see as this fold elongates from week 5 to week 6, the venous structure, the common cardinal veins, and the phrenic nerves are brought closer to the midline. And we note that this continuous separation between the lung mesoderm that's surrounding the lungs in these areas and the trachea that's developing breaks away from the mesoderm that is surrounding the heart. So the heart has to become a separate structure that's suspended within the pericardial cavity, so we've got to break that connection in this area here. So these folds are moving toward each other, and then ultimately we see obviously they are going to fuse together and separate the pericardial cavity from the pleural cavity. And there can be defects in this, and that's a part of what we'll see in the end. So the reason for studying in medicine, for studying very carefully the anatomical development of the organism, is not so much to appreciate the grandeur of it, it's more so to know how to repair it when things are wrong. And of course how to diagnose, differentially diagnose what it may or may not be, and thereby come up with a treatment. So this is a nice view that is in black and white, so very easy to take off these labels and put numbers on there and use it for exam questions. And again, that's the reason for including these in the lecture. Excuse me. So now that it isn't in color, we should be able to look first. Neural tube is dorsal, and we know that the notochord would be here. We can't really distinguish it. The aorta is developing in this area. Some other structures are developing over here. We don't quite know what they are yet, but we don't need to worry about it. Obviously, these are the limb buds. We come around and we see this fold on the side, a fold on this side with a structure within it, and we continue down to the ventral surface and we see this structure. Nothing else looks like this. Obviously has two chambers separated by a septum. Got to be the heart. And the dorsal mesocardium is connecting it to the mesoderm surrounding the lungs, and then the lungs are connected to the dorsal body wall through the mesentery. So we said that, and we'll advance to looking at this, that we're picturing two balloons pressing against each other, the two ends of the balloons, but now that once they get separated off, they're going to push together and come together. So if you picture two balloons coming together to squeeze around a pencil, you're going to have the pencil in the middle, and then the two balloons coming up back on one side and back on the other side. So if we put that into an organism, there's going to be a dorsal attachment and a ventral attachment. We don't see the ventral attachment, but we definitely see the dorsal attachment here with the heart and the lungs. So again, we're just trying to build this picture in our minds, and I apologize I didn't have the pip on as I was talking about the balloon and the pencil for the tape. But what I am going to do is just switch the pointer to a pen and do kind of a classical illustration that I have done for this. So over on this side, I'm going to draw one balloon and a second balloon, and these are going to move toward each other, toward the midline, and they're going to surround pencil, but most of them are tubes. So now on this side over here, we're going to draw the pencil in cross-section, and we're going to see that one balloon pushed and surrounded it like this, and the other balloon pushed against that balloon. Oh, I didn't quite make contact with it, but this will work, I guess, as well. So this will be a dorsal mesentery, and this will be a ventral mesentery. This is going to be parietal, and then this is going to be visceral layers of these balloons. So this is what we're trying to envision in our mind. It's a little more contorted. Actually, it's very much more contorted and twisted in the thoracic cavity than it will be in the abdominal cavity. But that's fine. So we've identified these structures here. What else was in this pleural pericardial fold? This structure, this big structure, was the common cardinal vein. What else was in there? The phrenic nerve. So the phrenic nerve was in there going down to the septum transversum area where we're going to develop the diaphragm. The phrenic nerve is the innervation of the diaphragm. The growing lung buds in the mesoderm in this area are squashing our balloon in that direction. These two structures are going to come together, the dorsal mesocardium and the pleural pericardial fold, to close off the pleural pericardial opening. So this label is saying the mesoderm surrounding the duct of Cuvier, which is the vein, the name for the vein. We would change this to pleural pericardial fold if we were to have it on the exam. And then this on the left side is pointing to the opening, the pleural pericardial opening. So identify the structure and identify the opening. So you, even though the image may not be so clear, you can see exactly what it's pointing to. Identify the structure is going to cue you that we're asking for this fold, pleural pericardial fold, and if we ask for the name of the opening, it would be the pleural pericardial opening. So now we can continue on with the development. So this was week 7 and 8, and we now see that the dorsal mesocardium, the dorsal mesentery of the heart, is gone. The heart is now suspended within the pericardial cavity. The pericardium is beginning to develop. There's a thick layer that develops, the fibrous pericardium. So if you've got connective tissue, we've all got calluses before. So if you rub something against your skin for a long period of time, you get if you don't get a blister, eventually you get a callus. Well, you have the heart beating away in this pericardial sac. Even in the embryo, you're going to develop a thick fibrous structure surrounding it that has some resistance and resilience. So the fibrous pericardium is beginning to develop, and we see that the phrenic nerve and the common cardinal vein will still be within the dorsal part of this, and it has fused, and we have completely separated the pericardial cavity from the pleural cavity. And it goes on to the 8th week to develop even more profusely into this kind of a V-shaped structure containing the lungs, the pleural cavity. And we see the phrenic nerve ends up very close to the heart, and the inferior vena cava is what ultimately, of course, is going to be produced by these cardinal veins. So because of the growth of the bronchial buds, the primordia of bronchi and lungs into the pericardial peritoneal canals, a pair of membranous ridges is produced in the lateral wall of each canal. Which of the following statements is false relative to this description? So you'll find these statements straight from the textbook, and it is set off in a separate paragraph. And the one statement that is false is the lateral ridges, the thoracoabdominal folds, are located lateral to the lungs. This is a false statement. So these ridges that we talked about, and we'll see it in another view in a moment, that they really are ridges. When you look at a two-dimensional cross-section, you see a fold, But when you picture it as a three-dimensional structure, it's an entire ridge. So we'll see that in another view in a moment. So there's a cranial ridge where the front end of our horseshoe was bent down, so there's a ridge as things push into the side cranially, and then there's a caudal ridge farther back along the length of this horseshoe-shaped balloon that we put together. So the cranial ridge is superior to the developing lungs toward the head, and because that's where it bends up around toward the head region from the lungs where they're developing. And then the caudal ridges, the pleural peritoneal folds, are located inferior to the lungs to separate the lungs from the heart. So there's two sets of folds that are going to contribute to closing off this continuous horse-shaped tube that we have to separate the pericardial cavity from the pleural cavity, and then ultimately as well from the peritoneal cavity. So we can switch over to talking about the peritoneum. Another name for the membrane layer that covers, that seals the abdominal pelvic cavity is mesentery. But this is a term only for a certain portion of this structure. So peritoneum is covering the entire abdominal pelvic cavity, and they are continuous with each other. So there is a mesentery, and then the two layers are visceral and parietal. So again, just quickly, I'm going to switch the pointer to a pen and recreate the picture that we had before, where we brought two balloons together surrounding a structure. We've brought our two balloons around, and they're surrounding a structure. So these are going to be the mesentery of the peritoneum, a dorsal and a ventral mesentery, and then this is going to be the visceral layer, the parietal layer on the body wall, and then the visceral layer is this layer on the organ. So that's our terminology, consistent with what we've been discussing all along the way. Now let's look at the illustrations from the textbook that make this point as well. So we have panels A, B, and C from figure 9-2 from the textbook. And we are looking at it from slightly different perspectives. This is a lateral view, just the surface view, and a classical approach, anatomical approach to structures is to look at the surface, distinguish surface features, and from that perspective, predict what underlies those surface features. And then you proceed to view the internal structures from a variety of perspectives or planes of section and views. So we see the heart prominence or heart bulge. There's a limb bud here. And then these structures that are the pharyngeal arches, that's our next objective that we take on in our study of the developing embryo. So now when we make a sagittal section through this structure, and we're really looking at the internal parts, it's not complete, but still is that type of a view. We have the foregut, the part of the yolk sac that's been pulled up into the head fold. We talked about the head fold coming down as the pericardial cavity and the heart move into the chest area. So it moves from being positioned straight out here. I'll go back to the pen for this. So we remember that the heart was originally out here. So as it moves in this direction, that is going to be ventral, and then it is going to move caudal to move into place here. So the primordial heart is going to move from its original position in front of the prochordal plate, first ventral and then caudal, and then it's going to fall into place into the chest cavity, where it will be anterior to the developing foregut and lungs. and at the tail fold, we are bringing the connecting stalk close to the yolk stalk to form the umbilicus, and with that tail fold, we are incorporating some of the yolk sac into the caudal region of the embryo, forming the hindgut. So the basic gastrointestinal system is there, created by the head and the tail folds to get a length of it, to have it divided into 3 segments: foregut, midgut, hindgut. Now when we make a cross-section, as shown here, the level of section C, and we look at the lateral folds, we see how the lateral folds are bringing the 2 balloons around, basically, to collapse upon this gut tube, and ultimately will form a dorsal and a ventral mesentery to form the peritoneal cavity. And we see that here in a later stage of the embryo. So D is about 28 days, and A is about 26 days. So in just a couple of days, there's quite a tremendous change to where the ventral body wall is going to close off, except for the umbilicus area that's developing here. We see the umbilical cord developing. If we take a plane of section through the thoracic region, we see that the ventral body wall is closed off, and the extraembryonic coelom, or the amniotic cavity, basically, is separated from the intraembryonic coelom. We see that there's still a ventral mesentery and a dorsal mesentery. So this is that structure that I have drawn a couple of times. One balloon collapsed against another balloon with a structure in between them. And so there's a dorsal mesentery and a ventral mesentery. Obviously, the dorsal mesentery is going to carry any vasculature from the aorta, and of course, this would be that neurovascular bundle with lymphatics that we mentioned last time. So we now see that there's 2 different mesoderms that are present. There's a splanchnic mesoderm, the intraembryonic splanchnic mesoderm. Do we recall that? Extraembryonic and intraembryonic splanchnic and somatic mesoderm. Challenge yourself to recall what structure was covered by the extraembryonic somatic mesoderm. The intraembryonic somatic mesoderm is covering the body wall portion. The splanchnic, intraembryonic splanchnic mesoderm is surrounding the splanchna, or viscera, or organs. So the somatic mesoderm layer is going to become the parietal layer, and the splanchnic mesodermal layer is going to become the visceral layer of the peritoneum, or pleura, or pericardium even. The point where the 2 layers come together are the mesentery. So as indicated here, the ventral mesentery typically will disappear. So here we have a slide. I'll take the pip off for this so you can see the arrow. With this bigger arrow, I guess it's a bit easier to see. So the question here is, identify the structure at the tip of the arrow. So what is this structure? Yolk sac, very good. What's this structure? Heart bulge. Surface anatomy, right? And at the tip of the structure here, what's the other big organ that's developing? Liver. So this is the liver bulge, and then this is the limb bud, and we see the developing umbilical cord down here. Okay. You can actually see some of the foregut within this general area here. So these are MRI views. Thank you very much, Brain. MRI views from different settings. I don't know enough detail to distinguish that, but we can see that we see basically different features with the different settings to collect this information from an MRI. So these are sagittal views of sagittal sections or sagittal planes through this same embryo, and I'll point to structures and ask you what they are again. So what is this structure here? Oh no, the heart bulge was a surface feature. We're inside now, right? So this is the heart, right? This is the wall of the heart and the heart chambers developing in here. And then I'll point over here. This structure down here, or even seen with the diffusion, we can see it over here. This is the liver. Okay, so this is that point of surface feature versus internal structure. So the terminology, the way that the question is stated, is extremely important as to what you're being prompted to answer. So this was the statement that I basically had made and illustrated with a pen in a previous slide. During the formation of the head fold, the heart and the pericardial cavity move blank to the foregut. So ventricaudal, so it's got to be either of these two here. So we recall that, I'm getting my pen back here. We started with the heart in front of the brain, and it went ventral and then caudal, and it ended up in front of the foregut. So which term is for in front of, anterior or dorsal? Anterior, so we already know that this is the correct answer. We've got 2 out of the 3. As a result, the pericardial cavity opens into the peritoneal canals, which pass obviously dorsal to the foregut. So the peritoneal canals are dorsal to the foregut.
Just a quick question.
Yes.
On that one slide, that was the black and white picture that had the pleuropericardial fold and the pleuropericardial opening.
Yes.
What's the difference in the opening? The fold contains the common cardinal vein and the sphincteric nerve, but what is the opening?
So the opening is the constricted or restricted space inside the balloon. So we have our balloon picture in front of us, the clown balloon that is bent around and folded under. And as structures are developing beside the balloon, it's pushing in. So those are the folds, and we'll see that they're actually ridges in the three-dimensional view. In two-dimensional, it's a fold coming in. But now if you step inside the balloon, so first you're in a balloon, you got nice walls like this. Now it's coming in, crushing in on you. So now you're in the opening. Okay? So the opening is inside the cavity. Well, it depends on whether you think the door casing is the doorway or the space that you walk through is the doorway. But either way, I mean, you see what I mean. You don't have a doorway to walk through if you think it's the space, if you don't have the casing around it. So that's a perspective thing. But basically, the opening is the space created by the structure around it. Within the structure around it, you have the folds. This is the only label on the right-hand side that actually is showing the fold. So, for exam perspective, you don't need to worry about this. You need to be able to recall that this one, when you're asked, there's only 2 lines here, one coming from the left of this embryo and one coming from its right. Typical way to show you things in medicine and anatomy. it's reversed. One will be you will be asked to identify the opening on this side over here, even if you can't see where the line ends. And this is the fold here. It is pretty complex in shape, kind of Y-shaped. And as well, this is the pleural pericardial fold on the opposite side. And the space, the doorway created by it coming in is the opening. Yes, but in reality, the space is the true opening. So if I told you to go stand in the opening of the doorway, you'd go stand in the space. It's surrounded by the door casing. Welcome. And so yes, if I am at Brooks, just hit your speaker, and we can have the same type of discourse through the magical technology. And the nice thing about having Marco here to help is that if you want to have it be more interactive, he can just turn on this microphone, and pretty much this microphone will pick up what you'd be saying. If I don't hear it, I'll say it, and then we can, rather than you having to push the button every time after I've said something so that you could ask again, we can just fire up the microphone system and communicate that way so that it's on all the time. So let's push through the last couple of minutes just to introduce the diaphragm. I thought it was only half a lecture behind, but it's getting closer to one full lecture. So we followed the septum transversum, and I think we can push through now that we're trying to picture these folds and everything, and view the formation of the complete diaphragm. So there are three basic things that contribute to the formation of the diaphragm. The septum transversum, you can see from the legend here. There's mesoderm within the pleural peritoneal folds. So there's pleural pericardial and pleural peritoneal folds. We're seeing the pleural peritoneal folds here. And then there is the mesentery of the developing organs in this area, the mesentery of the esophagus. So these three structures contribute to the closure of the thoracic cavity from the abdominal pelvic cavity, or in other words, the formation of the thoracoabdominal diaphragm. And then finally, there is a fourth component, a contribution from the body wall mesoderm, the somatic mesoderm, that primordia for the skeletal musculature of the diaphragm. And we see that the pleural peritoneal membrane, as we get down into the panel E, really diminishes, not so much that it disappears as it is everything else continues to get very big, and its original contribution does not change in size, and the septum transversum becomes the central tendon of the diaphragm that is surrounded by all of this skeletal musculature, including the skeletal musculature that develops around the major vessels and the esophagus passing through the thoracoabdominal diaphragm. So I will pick up with this slide, and we'll just push on through the remaining ones here, and we will, on Monday, try to get through as much of the pharyngeal arches as we can. Now that we've done a lot of this three-dimensional type of a thing, it'll be a bit easier, although the pharyngeal arches are still three-dimensionally quite challenging, but we'll push on through it. I appreciate your time and attention. Please tell me this is Friday. I need a weekend. I'll see you on Monday. Have a good weekend. Again, so used to lecturing from far away, I still talk as if I'm... So see you all on Monday. I went to Laura Mary's Journal Club presentation today in a classroom in this building as well. It was one of the first ones I lectured in that had the technology, and just has the television on the two sides. And so you're at the podium, and when you look up at your audience, nobody's looking at you. They're both looking off to, everybody's looking off to one side or the other. It's the weirdest feeling. You know, and at Brooks, at least I've got a television down here.
Right.
So most of the time my head is down because I'm looking at the television, and that's where the people are, you know. So I'm talking to a little television down. It's really an interesting experience.
Oh, okay. Yep, you too.
Good, thanks. The next exam is on the 17th?
I'm not sure. I thought it was the previous week.
Oh, okay. Yeah, it's on
Yeah,
the
13th.
13th.
There we go.
Monday. Okay, so I'm not going to, I just
Wait, that's
finalized.
coming Monday already?
No, God,
No, that's a week.
Don't do that to me. I've got a big grant to do, and then it's like, so I need a weekend, but my whole weekend, long days are going to be spent getting this grant together to begin circulating Monday. Then it's due a week after that.
Well, I've got the
So
exam
it's due on that day.
Mm-hmm.
But I travel to a meeting. I just finalized my travel plans today, so on the 15th,
Okay.
on the 17th, I'm leaving, so I won't be here. I'd already mentioned this to Nayeli. She's supposed to be working on the lectures for this to get the streaming video up. When I talked to her about it, I thought I was leaving on the 14th, so she's supposed to be looking at these and doing that. The question to you is, would you like to give the lecture in class? And,
I can do my best.
okay. Or you can just take a segment of it if you want, and present a segment of it.
It should be fine.
Yeah. Great. Appreciate that.
Mm-hmm. And then
Yeah, I think at that point it's mostly
not a whole lot of histology, right? You really suck at histology.
Well, I kind of think that is the well, it is the histology, getting down to the thin membrane, I think.
Mm-hmm. Yeah, I actually sort of remember that stuff.
Yeah, it's not really
Yeah.
too awfully bad.
Yeah, I'll give that lecture. That's not a problem.
And the fistula.
Mm-hmm. Yep, sounds good.
Yeah, that should be all right.
And then you still wanted me to do the other two lectures, right, for this section?
Yeah, if you do get the chance. Now, I believe I copied you on an email with, or did I, with Jay Lundgren?
No, I'm not sure if that's that.
I think I had mentioned that I'm hoping to get, a few of the graduate TAs that are working with the WebCT, at least to meet with each other.
Mm-hmm.
And the department is also supposed to be hiring a department IT person whose responsibility will be to work with faculty on their WebCT.
Right.
And the suggestion that I made was that they try